Thank you. First of all, thank you for inviting me over here, and thank you to everyone who is online right now, ready to watch this awesome conference. My topic today is custom ESLint rules with Angular schematics. And let's go to the next slide. My name is Stanimira Vlaeva. I'm a software engineer at VMware and also a GDE for Angular. The best way to find me online is on Twitter. And today we will be talking about breaking changes. And one thing that we know for sure is that nobody enjoys breaking changes. Honestly, because developers are paid to build new features in most cases and not to update to the latest version of any library. But as we can see in today's world of JavaScript libraries and not only JavaScript, updating to latest doesn't have to be hard. It doesn't matter if you're an application developer or a library maintainer. You can also, you have options to make updating to your latest version easy. And I want to promise you that after this talk, you will know how to make breaking changes painless. If you're a library maintainer, you will learn how to integrate the NGUPEx command so that your users can update to the latest version and execute migration scripts instead of migrating manually. And also, if you're an application developer, you will learn how to use ESLint to disallow any deprecated APIs and even migrate them yourself. So let's get started. The first piece of the puzzle is ESLint, as you can probably guess from the title. And ESLint is a JavaScript linter, which means that it analyzes your code and it finds problematic patterns. But enough here, let's see how it actually works. I have a very little project here that I really hope you can see. I have just a single file in this project. This is the index.js file. And I have a couple lines of code. And as you can see, there are some missing parts of the code or some stylistic problems, depending on anyone's opinion, of course. For instance, we don't have semicolons here, and we're also using the var variable. And because I have set up ESLint with a style guide that disallows the var variable and prefers using const, and also disallows omitting semicolons, when I execute ESLint, it is going to traverse this code and find these problems and report them back to me. ESLint is a dependency to the project. That's why I can execute the binary in the ESLint package using NGUPEx. I have to specify the source directory that I want to traverse. And when I execute this command, I get a bunch of errors, which is a good thing in this case. We want to see errors today. And as I told you, we get the no-var rule firing, which says that I'm using var over here instead of let and const. And I also am missing some semicolons. Another error that I get is that the variable b is assigned a value, but it's never used, as you can see. And these are quite easily fixable errors, but we can also have much more complex rules. The things that we see over here are called rules, and they're specific scripts that ESLint uses or applies onto your code to report errors. Another cool thing about ESLint is that I can execute it with the fix option. Let's see what happens if I do that. Well, first thing that is obvious is that we get less errors. And something else, as we can see, is that we have changes to our code. So ESLint executed some modifying scripts or migrations, as I'm gonna call them from now on. Let's see what are the differences. Well, we have semicolons. These are the fixes that ESLint executed for us. So we have a couple of different parts to ESLint. First of all, we have rules that are being applied to our code, and we get errors out of them. But each rule can also have a fixer. This means that whenever we apply the rule to our code, we get some fix applied. And today we're going to learn how to write our own rule with a fixer. And in order to do that, we have to understand a little bit how ESLint works under the hood. We have our source code, and ESLint runs that through a parser. In the default case for JavaScript, this is a parser called Esprit, and the parser produces a data structure called abstract syntax tree. This is how a specific example looks like. We have an import declaration. This is the source code that we have, and this is the abstract syntax tree that is being produced by the parser. As you can see, we have one root node, which is of type import declaration. The import declaration has some specifier, and for instance, a specifier is the search bar that we're trying to import, and the import declaration also has a source. And in this case, the source is UI search bar. As you can see, we have different nodes, and each node has its own type. And there is a specification for that you can totally find in Google. It's open source, but you don't have to learn them or know them by heart or anything like that. We have many tools that help us traverse and understand these abstract syntax trees that are being produced by the parser. So why do we need to understand them after all? Well, because ESLint applies rules using that abstract syntax tree. And the rules, as we saw, produce reports which can contain errors and also ways to fix these errors. And the cool thing about ESLint is that it is highly customizable. We can have custom rules that we're going to be writing today. And the custom rules can produce custom errors and also have a custom defined way to fix our code. And even the parser part of ESLint is customizable. So if you want to apply ESLint to a TypeScript project, we can use the TypeScript ESLint parser. And in our case, if we're writing Angular, this is the parser that we will want. But I mentioned TypeScript here. You might be wondering, why aren't we using TSLint instead? And the reason for that is that TSLint is deprecated in favor of ESLint. And most of the JavaScript ecosystem has migrated already. And if you're not there yet, so don't worry about it. It can be relatively easy depending on your current TSLint setup. But there is a guideline and ways to migrate from TSLint to ESLint. So in that spirit, we'll be using ESLint today instead of the deprecated library. And as I mentioned, we can write our own ESLint rules to detect deprecated APIs coming from libraries or coming from our internal applications. And we can also fix these deprecated APIs. And the other part of the presentation today is how are we going to apply these migrations out of the box. For instance, if we have a library that we're shipping to NPM and our library users that are installing it, how are they going to get these migrations without having to do any manual setup? Well, Angular is already doing that with the NGUpdate command. As you know, when you execute NGUpdate and provide it with Angular core and Angular CLI, this is going to update to the latest stable versions of the two libraries, and then it's going to execute some migration scripts that help you update to latest. Let's see that in action in case you haven't used the command. As you can see, we are installing packages from npm, and then we are executing some migration scripts. And our project is already ready to use, hopefully, with the latest version of Angular. And because the Angular team is quite thoughtful, they made the NGUpdate command extensible. So we can use NGUpdate for our own Angular libraries. And today I'm going to show you a little bit different approach. And this is how we can integrate an ESLint rule within NGUpdate. So we're going to have both, the best of both worlds. We're going to have ESLint whenever we want to manually execute that on our source code and have it report errors. And we're also going to have an NGUpdate script that uses internally this ESLint rule to migrate any application that that executes the ngupdate command. I basically told you that on the previous slide. So we're going to write an ESLint rule, and we're also going to integrate the rule inside the ngupdate. And we need a deprecated API to migrate. This is a real-life example from a library that I used to work on called NativeScript. Any fans of NativeScript? Ooh, I can't hear you. Anyway, so before we had imports from UI search bar, and the new API is the, TNS Core Modules UI search bar. So basically, we have a very common scenario where a library deprecates some API, and it introduces a new API that should be used. And this can be considered a breaking change, of course, if the previous API is removed. So let's write an ESLint rule to migrate this API, right? And for that, I'm going to use a website called AST Explorer instead of a local setup, because you can very easily after this talk go on and try it on your own without having to do anything manually. And the AST Explorer is a very, very useful tool because it shows us our source code over here, and it also shows us an abstract syntax tree over here. So this is the result whenever the parser runs on our code. And as we can see, we have a single node that is an import declaration. And if we traverse it any further and select this part of the code over here, we're going to go to the specific type that this gets parsed into. And this is the source of the import declaration that is of type literal and has a value of UI search bar. All right. Just to mention that if you're trying this on your own afterwards, you have to select TypeScript ESLint parser if you want that rule to work with TypeScript. And over here is where we will be writing the rule. And this is the output whenever the rule is being run to our code. So what we want to get eventually is that we want this code over here to be fixed and have TNS Core Modules /UI/search bar. So how do we do that? This is essentially the rule, an empty rule. And this is a function that has some context and returns an object. And inside the object, we have to declare every single type of node that we want reversed. And in this case, of course, we can have many other statements that we don't want to traverse. We want to report only over here. And this is why we have to select any import decoration. And to do that, so the key of the this property should be import declaration. And the value is a function. And the function accepts a single argument, that is the node that is being traversed. And just to make sure that it works, let's just quickly walk the node. You can use the DevTools console, of course, and we have the node import declaration. If we look at the source, we can see that it's the exact same node that we want to traverse. And as you may guess, we are going to use the source to detect if this node should be traversed. So let's go to node.source. Sorry. And we will look for the value of the source and see if this equals UI search bar. And if we have a node like that, this means that this is a deprecated piece of code. We want to report an error. In order to do that, we use the context object and the report method on that object. And inside, we have to provide the problematic node. And for that, I'm going to provide the source. So this is going to be underlined by ESLint instead of the whole statement. So the node is node.source. And for a message, we can totally write anything that we want. For instance, importing from UI search bar, it's deprecated or disallowed. This is a little bit more ESLint way to say it. All right, so we can see here that when the rule is fired, we get an error at the exact same line of the code that we want. And we get an error that importing from UI search bar is disallowed. But this is not enough for us. We also want to fix that code. And in order to do that, we have to provide a fixer. A fixer is a function that takes a single argument called fixer, and it has to return something. And in this case, we want to use the replace text method on the fixer. The node that we want to replace is node.source. And because it's quite simple right now, we know that we have UI search bar. I'm just going to copy this over. And I'm just going to add TNS core modules UI search bar. And I get an error. And this is because I'm actually replacing it with a plain text and not a string. This is why I have to add quotes over here. And this is our migrated code. Of course, if we want to preserve the original quotes, there are other ways to do it, but we're just not going to get into that. You have to basically use the raw value and replace whatever you want to replace there instead of modifying directly the value and adding your own quotes. But we did what we wanted. We have our deprecated API. Sorry. So we had our deprecated API, and we migrated that. You can find the code later. I have the more sophisticated version of this rule in a separate repo that you can see and use for your own projects. All right, how do we distribute this rule though? Well, the way to do it with ESLint is by using an ESLint plugin. And the ESLint plugins are distributed as nodes as NPM modules. And yeah, basically you just put custom ESLint rules inside and distribute as an NPM module. The name format for the plugin is ESLint plugin / the plugin of your the name of your plugin, or you can also have a scope. And in the case with NativeScript, we have ESLint plugin NativeScript, and the other option for a name is @NativeScript / ESLint plugin. And inside the plugin, of course, you're going to have your rules in rules directory, for instance, and you have to have a main file which exports these rules in the following fashion. So our rule is going to be called no short imports in a dash case, which is the default or recommended practice for naming ESLint rules. And if we want to use the plugin, you have to first add a few dependencies, the plugin itself, ESLint, and also the TypeScript parser if you want to use it in a TypeScript project. Then you need an ESLint configuration file that is quite short, so no worries about that. Here we specify the parser, a couple other stuff, and we also specify the plugin that we want to use and the rule and what kind of error it is going to give. So this can be either an error or a warning. So in this case, we want this to throw an error. And whenever we want to use it, we can just execute the ESLint command with extension TypeScript. If we want to traverse the TypeScript files more specifically, we want to traverse the source directory, and we also want the fix option. And let's see what happens when we do that on our project. So we execute it without fix, we get the error that we want. Then we execute it with fix, no errors, and we see that our code has been migrated. Cool. Now, how do we integrate that with NGUpdate? And I'm not going to do any more live coding because I don't want to bore you from the start of this conference. So let's just get into some theory. Internally, NGUpdate uses something called Schematics. And this is a library for running project transformations. So for instance, we can have scaffolding files, updating files, or executing some tasks. And the Angular COI uses schematics internally quite extensively. For instance, the ngGenerate command uses schematics to generate components, modules, services, and whatever you want. And because I said whatever you want, you can actually extend the ngGenerate, ngUpdate command with your own schematics. So, for instance, you can have your own collection of components and use ngGenerate to generate them in the fashion that you want instead of generating the built-in components. NGAdd is also a command that uses schematics internally. For instance, we have NGAdd NativeScript schematics that installs the NativeScript package in your project, and it also executes installation schematics that are defined inside this library. And of course, NGUpdate, as I've mentioned many times so far, also uses schematics. It updates to the latest stable version of the library, and it executes the migration scripts defined inside this library. So how do we make our Angular library NGUpdatable? First, you need an NGUpdate key inside your package.json. And this NGUpdate key should have a migrations key that points to a migrations JSON file or some JSON file. The name is not that important. The migrations JSON file is a schema file that defines your migration scripts. And here we have just a single script that is going to be executed whenever we are updating from some version to version 002 or to a higher version. And the code for this migration is inside the factory. You don't have to remember all that. I'm just walking you through the setup. And inside this factory, we have something weird, a function that returns another function that returns a tree. And let's take a step back and learn some theoretical things about schematics. The most important concept in schematics is the tree. And the tree has a base, which is a virtual representation of our file system at the current moment, and actions. And these actions can do things that modify your files in that file system. For instance, we want to modify the package.json to add some package inside it, and we want to create a new file and other things like that. A rule is a function that takes a tree and returns another tree. And in this case, we have a tree with no actions, and the result is a tree with some actions. And the actions are going to be applied whenever the schematics script finishes. So we're accumulating them in this actions array, and then we are applying them in the end, which means that they are also reversible. If some action fails, the whole transaction is going to fail. So we're not going to end up with some broken project. And a rule factory is a function that returns a rule. And this is hence the name factory, because it's essentially a function that returns a function that takes a tree and returns another tree. And we can see that here. We have our rule that takes the tree and returns the tree, and we have our rule factory. And this is essentially where our migration is going to live. So first of all, how do we provide options to this schematic? Well, we have another key in the migration schema that points to another schema file, which basically contains the properties or the options that we can provide to our migration. And in this case, we have only the project, and this is going to be inserted by the Angular COI whenever we execute the ngUpdate command. So it is not something that our users should provide whenever using the migration. And in order to extract this project name, we use the options argument in the rule factory, and then we extract the project from these options. So far, so good. So how do we do stuff with schematics to modify our project? First, we can read files by using the tree read method. And this is going to return us a buffer, and this buffer is going to be converted to string. This is a function that we're going to be using throughout our migration. We can read directories by using the getDir method on the tree, and we get an object that we can basically use to traverse recursively every single path in this directory. So it is not an array of all the files or anything like that. We have a visit method that can be used to traverse each path. And in order to edit files, one way, the easiest way, honestly, to do it is by using the overwrite method. We have to provide the path to the file and the content that we want to insert there. All right, we want our schematic to do the following. First, we want to find the source directory of the project. In our scenario, or the default Angular project, this is the src directory. Then we want to read all TypeScript and JavaScript files. And then we want to apply the ESLint rule to their content. And if there are any changes, we want to rewrite the files with the fixed content. So let's do that step by step. First, to find the source directory, one way to do it is to read the Angular JSON file, then parse its contents, and then just grab the project options from the workspace. Then how do we find the JavaScript or TypeScript files? Well, here's a little util functions to do that. First, we have the disallow extension helper function that checks if a path ends with TS or JS. Quite a simple way to find the TypeScript or JavaScript files. Then we get the source directory, and we visit every single path in this directory. And if that path has a TypeScript or JavaScript extension, we add it to a set. And finally, we return that set from the function. And finally, applying the role itself. First, we have to import a linter class from ESLint and instantiate that. Then we define the rule that we need. Then we define the parser that we need. And then we run the verify and fix method through every single file that we want to fix. And we get the fixed content. How do we rewrite the files? Well, basically, we get every single file path that is TypeScript or JavaScript. We apply the rule to it, and then we check if the content is different from the original content. And if that's the case, we run tree.overwrite. And let's see how that looks like if we use NGUpdate for our demo library with this migration script. First of all, of course, NGUpdate is going to update to the latest version of this library. You can see the package.json file here being updated. It's going to run npm install, and then it's going to execute a migration. And as you can see, we have the exact same result that we had when we executed the ESLint rule. I'm not going to watch that to the end once again. So that was everything that I wanted to show you today. You can find all these examples in the links over here. The first link is a link to the presentation, which also has links to all the other examples. And if you want to talk to me, you can find me around or in Twitter. So thank you so much, and I hope you have a great conference.